Now in sampling record, just now I am discussing about that. Identification mark, sample, sample number, and sample number for the project. You must design such a way it should be a unique number. So when you start from January to December, the sample number should not be repeated. Otherwise, we have seen that every day the new number they put. Every day 123, next day date 123, which is not realistic or proper to have a proper identification. So we should have serial numbers. When you start from the project, maybe from January, you start 0001, and then you continue that number for entire till December end. So any sample is very easy to identify, and there is no duplication of samples. So you should have alphanumeric number. So you can decide. You are free to do that. See that it should be always a unique number. So there is no confusion about sample taken on Monday or sample taken on Saturday or any day should not be combined. So that one has to see. Sample type is composite sample or spot sample. Composite in the sense you take number of samples, make a sample and use it. Spot sample, only single sample you take only for checking workability, suppose. So that is a spot sample. But when you are taking for other tests, like compressive strength is there, density is there, all any other test you have to do, it's better you go with the composite sample. Don't go with the single sample. So when it is falling from your transit mixer, you take incremental samples, number of small samples, collect in the container, mix it properly, and then that is a one sample. Now you can identify the numbers and other things. So type, grade of cement admixture that should be appear on that particular sampling record. Identification of work in the sense that which project, which structural element we are going to use this concrete. That has to be maintained properly. Column, slab, footing, or piling, whatever is there. Now they have got again individual identification mark for the particular grid. So we can put that also, or you can put grid also. XY grid also we can put. Then identification of batch and transit mixer. Now each transit mixer is carrying their batch sheet always. So that batch number or batch sheet we have to write, and or transit mixer is there, you can put the transit mixer number. So we will understand which transit mixer I have taken the sample. So there may possibility something, maybe some wrong with the particular TM also, that you can identify, and it is where it is placed. Suppose you are putting a very big slab, so this particular TM goes into this portion. So we can just put a note that this from this TM we have placed the concrete. So anything goes wrong later on, you can identify that area and concentrate on that area how to take a call on this particular TM. Suppose there is something wrong. Ambient temperature, as I discussed earlier, and concrete temperature, both are important, and both the things are always specified. What is that? What should be the temperature of concrete during placing? If the particular temperature is exceeds, we have to follow different norms. There's a different codes are available for this. When you are working for cold temperature or any hot temperature in the month of May, the temperature, ambient temperature may be 45, 50 degrees. So there is a norms specified by the Indian standard, guidelines are available. You have to follow those guidelines. For that, you must know what is the temperature of concrete, and accordingly, we can take a call. Then declaration, the person who is taking the sample, whether it is as per the standard, they are taking the sample, and name and signature of the responsible person for sampling. This is also very important. So this type of record we have to maintain for each sample. Now part 2, we talk about the slump test, PB test, compacting factor test, degree of compatibility, flow table test, and VB test modified. Now it's very popular test, you can say, is a slump test, and very easy to perform at site. But now, if you look at it, current scenario in Mumbai or wherever you work, slowly this taste is going away. People are not doing because people want high workable concrete. So whenever there is a high workable concrete, this taste is not applicable. This taste is applicable slump up to maybe 160, 180 mm. More than that, this taste is not applicable for the concrete. This one has to understand. Now, I'll not discuss much on this because everybody knows about this taste. This is a slump cone, and concrete which is slumps, because if you see the dimensions, 10, 100 mm, 200 mm, height is 300 mm. This is a basically inverted cone, custom of cone. Once you remove, you get like this: true slump, shear slump, and collapse slump. Now, once you get this level of slump, this test is not applicable. Then we have to go for the another test. But when you are designing concrete in laboratory, slump is a very good indication about giving about the quality of your mix. One, you are compacting in 3 layers, each layer by 25 strokes. So well compaction. Even after this compaction, you will find there is a lot of voids inside. It gives that concrete is stiff. If this is a shear, it indicates that concrete is having lacking in fines. So a lot of information is available on concrete once you do this test. So it is very important to understand the test, but you must understand their limitations also. This is the setup for the slump cone, tamping rod, scale, scoop, and this is at the top, because at the last layer it is very difficult to compact within the cone. So we can put this as a cone, and we can remove this and take a call. So this is what is happening. You can see here, take the slab, and this is the, see, this is the concrete. Now, as I said, true slump, no slump, zero slump. See, even in compaction, you will get this type of voids, though it is compacted properly. It clearly indicates there is a no workability. So even with the such a high compaction, 3 layers, 25 stroke each, still there is a void. This is required more workability. This is zero slump. So this is true slump. This is a collapse slump. Once there is a collapse slump, this test is not applicable. You have to go for the another test that we'll discuss. And shear slump, if you get, it all indicate that your mix is not having proper fines content. So there's no proper binding in the mix. So one has to understand that, and accordingly we can design a Same. See here, 3 into 25 stroke. This is the tamping rod. Dimensions are also given, and and have small video. Now this is the older version. So in this they are given 4 layers, but now it is revised for 3 layers. Otherwise, everything is okay. देऊन टाका. हा 12 वाजता. This is 4 layers because earlier version was 4 layer. Now it is in 3 layers. This is what happening on the most of the site. Torsion motion. Now this video is available on our website. Anybody wants, they can upload because we have prepared this video for engineers. You can go for this. So here one or two points is very critical. We should not twist the cone. Then your values will be different. So whatever precautions we have shown, that one has to stick to that, and accordingly we can take a slump. And true slump will give huge values, and that feedback we can give it to the RMC fellow to subsequently, is there any correction required, can be given to them. Now, next test is VB test. This is basically a same slump cone test, but it is fitted on vibrator. So now once you fill this cone, it will become a frustum of cone. You remove the cone, put this glass plate and start your vibration. And this frustum of cone become a cylinder once it is concrete touched to the total glass of this become a cylinder. The time taken to that from frustum of cone to cylinder is called VB time. Now VB time is less, your slump is high. Suppose VB time is more, your slump is high. You can see here VB time is 2, we can have say 70 mm. If the VB time is 6, we can have around 10 or 15 mm. So it gives indication what type of vibration required for the concrete. It gives very rough idea about how much time I have to vibrate my cubes or specimen or in the field. That is the indication of this VB degree. But this is generally a very laboratory test only. We never use in the site. Site we use only slump test. But to understand level of vibration required for the particular concrete, you must get this data from the laboratory when you are designing a concrete in the laboratory, and which is useful for your vibration in the field. This is what same picture. Another test is your compacting factor test. It is also test gives you idea with the self weight of the concrete fall into the cylinder without any external energy gives a particular compaction level. Now, once that is there, you take out this cylinder and compact with the standard manner weight of the fully compacted cylinder and take the ratio of that. If the ratio is 1, means your concrete is highly workable and no compaction is required. Is a 0.8, 0.85, they are specifying. Accordingly, we have to adjust. This is also a laboratory test, very good indication about the compacting factor of particular mix. It is also a laboratory test to this. So we will not spend much time on this. Now another is this is new test included in the code for find out the degree of compactability. How much concrete has to be compacted with the vibration or vibrating table or internal vibration. If the ratio 1.04 to 1.4, so you can go through the details about 1199. Is a new test. It gives very good indication how much concrete whatever you are designed. You're having a proper slump, but whether it is really compactable, whether you can compact properly, that indication will get with this particular test. This is a new test included in your IS code to understand the level of complexity, especially when the concrete is low slump, when you are working for suppose pavement quality concrete. Your slump is around 25-30 mm slump. And there what level of compaction required. If the valid range is this, then you have to reject the concrete. Reproportioning of concrete is required with the proper amount of water content and admixture content to get the ratio in between this. H1 divided by H1 minus H2. That is the degree of compatibility. Now this is a very important test. Now we have to generally we have to accept this that whenever we are working for high workable concrete and that concrete exposed to vibrations. The two things is happening here. high workable concrete but not self-compacting concrete. So we have flowable concrete, but it's required a vibration. For that, this test is there. And this is very important nowadays. The way we are doing concreting at project site, most of the concrete we are doing a flowable concrete. So there is a term people are using free flow concrete. There is no free flow concrete. We have a high workable concrete or we have self-compacting concrete. But this test is not for self-compacting concrete. This is only suitable for the concrete having higher flow. When the slump, we are saying more than 180 or 200, slump test is not valid. Then we have to go for such test. So we have to remember this flow table test. Earlier this test is also given in the IS code 9103, which is for your admixture. So that same test now they are included in the 1199 fresh properties, the flow table test, and concrete, high workable concrete subjected to the vibration. For that, this test is specified. So flow between this and this is after tamping. This is the flow table. This is the cone and this is the compacting rod for this. This is the wooden rod, 40 by 40, 200 mm in length and about 150 is your cylinder. This is a 200 dia, top is about 130 mm, height is 200. This is not a slump cone. This is a floatable cone. Just to put it here, compact in 2 layers with this rod, and then you lub the cone and then subject to tamping of 15 times to get a spread for the particular. This is very important test, and now most of the concrete we use high workable concrete, and everybody should understand. Now slump test slowly replacing by this test. The slump has very limited scope at the construction site nowadays, the way we are working today. This is the actual photographs of the equipment, flow table, and this height is 40 mm. So we have to lift 40 mm and drop it for 15 times. With that impact, your concrete will get sprayed, and that spread you have to measure. That is called flow. And that drop is basically having a simulation of vibration. So any segregation takes place or bleeding takes place, everything we can understand this particular test. How the concrete is good, how the concrete is bad, we'll understand from this particular test. See here, first is lift it and then lift 15 times and get a spread. Now see the spread here, there no bleeding, nothing, but concrete is there. So once you get this concrete and vibrate, you will get this concrete. So there no bleeding, no segregation. So such a good concrete is required. This small video, site video is there. You can see here. This is what we have taken from site itself. This is the tamping rod. Lift the cone. See, this is what without vibration. Now you lift this for 15 times and see what is the spread. See, now you can measure the flow. So after vibration also concrete is not segregated. That is the proper designing of your mix. That one has to underrated and maybe around 600 or yeah 620. And so when you put in the forms, it is always with a vibration and without any segregation. This is what we are aiming at, proper concrete. But if you get concrete like this is not acceptable. See, the slurry has flown out. Your aggregates are here. Now same thing goes in the form. In the suppose in the column, you will find that all aggregate is settled down and top we got this only cement slurry, and this will have very high cement slurry at the top layer and it will find it as cracked because high cement will have always tendency to shrink. So this is what difference in this. So this is not self-compacting concrete. It is a high workable mix. Till you can vibrate and you get like this. This is the best concrete. This is the bad concrete. So one has to understand when you get the concrete like this, definitely there is the issues in when you put it in the forms, column, slab, whatever you do, you get a lot of issues in the concrete. See, this is also. This is what we have taken actual photograph the site, how the concrete is behaving with the for the vibrations. So what we are looking at, this type of concrete always. It is also flowable, about 600 mm flow is there. But still it is a, you can see aggregate everything is come to the circumference here. All the face, there is no segregation. But if you see here, see this is also flowable concrete. But if you put this in forms, you'll have issues. Even if you put this concrete in the pumping, you'll get a lot of issues of pump choke ups. Because under pressure, this water will squeeze out and will get next moment it will form with choke up. That one has to understand. So most of the concrete, when you design for high workable concrete, you must understand that how to design concrete for vibration. Another point you have to remember, this is not a self-compacting concrete. Self-compacting concrete, we are not vibrating. Here, most of the concrete we are vibrating is feels that you have a very good flowable concrete. If you don't vibrate this concrete, there is a lot of issues in the structure, maybe in the column or slab, you'll have a lot of issues. You feel it is a flowable concrete, but it is not a self-compacting concrete. One has to understand. So this is the how a cohesive mix, proper mixing. So this is a very important test for high workable mix, which is slowly replacing your slump test because our requirements are changing at the field. Now you must have heard about my one concrete. At a 3 meter level, you have all elements you are casting in one go. So it's very difficult to place the concrete with the slump. So you have to go with the flow. Now once you go with the flow, one has to understand it is also you are vibrating that concrete. Otherwise, you can design for self-compacting concrete. If it's not possible, you design such a way that even with vibration, it should not segregate. This one has to understand very carefully about this. Why I am spending more time on this? Because now whatever concrete we are handling today at the project, we are working at floor like concrete only. Because of ingredients and change. Now we are getting all crustone sand. Your admixture are changing from SNF to mid PC or high PC, low PC, polycarboxylate admixture, what we have seen earlier. And that will tends to give only a flow. It's very difficult to get the slump, except very few projects where you are working, like suppose I am working for pavement quality concrete, PQC, where you are using pavers. There, this concrete is not applicable, not advisable rather. So better you go with the slum concrete. And there the type of admixture to be used is totally different than what we are using for normal constructions. Because there we are looking at the slump about 25-30 mm or 20 mm rather, ideal slump. So that one has to understand, and accordingly we have to design your concrete. So this is very important. You must study this for flow test and slump test, compare, see the difference, and depend on your application, you must ask RMC fellow to get a concrete as per your requirement. Now this flow, what we are talking at your placing point. Suppose I want 500 or 550 plus minus 50 mm at placing point, and your RMC plant located maybe 2 hours or 3 hours from your project site. So what we are looking at after 3 hours, once you receive the concrete, this is, and it should remain another 45 minutes required to empty out your transit mixer. So you need required at least 3.5 hours working time without segregation. That is the skill. How to design a concrete having retention of flow up to 3 hours or 4 hours. Because over 2.5 hours only goes for your transit time, means travel time only. Once you receive, you get this flow, but there shouldn't be drop in the flow suddenly. It should remain for at least 30 minutes to 45 minutes to pump the concrete. And once you pump the concrete, it has to be vibrated and then do the finishing. So you need at least 45 minutes for that, half an hour to 45 minutes. So all this time you have to consider, and accordingly we have to ask the RMC vendors to get my concrete at particular flow and cohesive mix, not mix like this. It is not acceptable. There are a lot of issues in the structure. So what we are looking at this one. I think this test will discuss in next lecture. So any question is there, we'll discuss for this, because I spend more time on this because this is the today's requirement at sites. And people are civil engineers are confused with free flow concrete, self compacting concrete, and high workable mix, high slum concrete. We have discussed about slum test, limitations of slum test, and for next is you go for your flowable concrete, which is we are not discuss about self compacting concrete. We are asking about a flowable concrete or high workable concrete with vibrations. Definitely with the vibrations. So once you vibrate the concrete, there should not be any segregation or bleeding in the concrete. And that is the way you have to design your concrete properly, where our structure will having a without any issues. I think I'm stopping here. Any question is there? We'll discuss for 4-5 minutes and then we'll close this. Yeah.
Yes. Yeah, students can ask directly. If you have any questions, unmute yourself and ask.
Because this is very important, because when you are handling concrete at site, you must understand your requirement, and this requirement has to be given to ready mix concrete people or the laboratory where your QC engineer is sitting to get your concrete as per your requirement. Today it's possible to get concrete as per your requirement. Yeah.
So my question is, what is the maximum uh, diameter we can achieve
700,
without segregation? Okay,
700,
700.
700 mm. Should not go more than 700. Generally, we specify 550 plus minus 50. That is a normal requirement for the wood concrete
Okay.
without segregation, without plate. So when you talk about self-compacting concrete, we will discuss that high workable concrete, but self-compacting concrete where vibrations are not advisable, or you should not do the any vibration.